We're now ready to kick off day 2 of SOC core skills. And we're going to start off with the Linux section of the class. As I said, there's a lot of labs, a tremendous amount of labs that we will be going through over the next few days because we believe the best way to learn is by actually doing things. And while we're sitting here and we're talking about these labs and we're talking about Linux, we should get ready for the labs by going ahead and starting up our VMs. So I'm going to go ahead and get logged into MetaCTF like so, and you should do likewise. And I'm going to go to Cloud Labs. Oh, I'm going to accept all these cookies. There we go. Cookie starts with C. And I actually think I forgot to shut off my VMs yesterday. So I've only got 3 credits. That ain't enough to get me through. So I'm going to put Roman's child through college. I'm just going to buy this many credits. I'm going to buy 25 credits. It does all of its verification via cell phone, like all good security practices. So I'm going to go ahead and put that in. 809,959 and oh, that wasn't it. Maybe I didn't type that in right. 809,959. It says do not share this code with anyone, least of all a class of 150 people. All right, so we're going to go ahead and pay. Processing. There we go. What did you do in class today? I bought stuff on MetaCTF. All right, so now I'm going to view and manage lab. And I'm going to go ahead and start all virtual machines. It's going to take about 2 minutes for it to start completely, which is more than enough time for us to get started with the slides for Intro to Linux. Now, we're going to be covering Linux as an operating system more from the perspective of how do we deal with Linux if we believe it to be compromised, because that's the funnest way to do it. Because honestly, you could go through with Linux and you could do it like Ferris Bueller's Day Off, where it's like, okay, well, we're going to be running the ls command and ls, anyone, what does ls stand for? And it'd just be horrible. It'd be boring. But now we're like, you're hacked. And now you got to find the hack on your computer system, and then you can start working through to discover that hack on your computer system. And that just seems a lot of fun because that's actually how I've learned everything in IT. Everything I've learned in IT has all come from like hacking and security. And if I can break into it, I'm interested in it. It's like technology is not fun to me unless I'm actually trying to hack it. But Linux is my favorite operating system. Right now, I'm kind of distro hopping at the moment. I use Pop! OS quite a bit, and then their notebook computers aren't as good as they were. So I switched over to Debian. Debian is my current favorite, but at the very moment, this particular computer, I'm running Fedora, which brings me to a point about Linux. How many of you are familiar with Linux? I actually answer that question by typing in your favorite Linux distro. Think about all these people that are talking about their favorite Linux distros. And if you have a group of people, they're going to say Debian, they're going to say Ubuntu, they're going to say Red Hot, the Red Hot Debian peppers. We've got Kali, we've got all of these different distributions that are out there. And here's the problem. Anytime you ask a group of people what their favorite Linux distribution is, you get like 30 different names of Linux, right? You know, Knoppix STD, Arch, and so on. Now, my question for the people that aren't familiar with Linux is, does that make you feel better or feel worse about Linux? Like, if we have people that are throwing out Gentoo, SteamOS, Red Hat, Fedora, all of these Linux distributions, if you're someone that has never used Linux ever in your entire life, you're just kind of like going, what the? I'm like, what am I going to do here? Like, do I have to learn every single one of these distributions? And then some ass just shows up and is like, well, I'm a big fan of FreeBSD. And it's like, no, it's even worse. Oh, dear God. Oh, dear God. Don't panic. Don't freak out. It's fine. Your head doesn't have to explode. It's going to be okay. The reason why is because when you're learning Linux, it doesn't mean that you have to learn every single distribution. All right. You don't have to learn Red Hat and Debian and all these different things. There's going to be some changes in how they do package managers. Don't get me started on package managers. That's a whole nother rant to the OSI model. We'll be talking about that more in a little bit. But by and large, if you know how to use Bash, you're going to be fine. Because at the core of all these Linux distributions is Linux. The operating system. And then like the next step from that, people are using bash, the born again shell. That's the command prompt that we'll be using. Now, Kali uses a slightly different one, but it's compatible with bash. If you have people that are using Z shell, it's compatible with bash. So if you learn how to use bash, you're then going to be able to then use any other Linux distribution of your choosing. And that's the power of Linux. If it gives you that flexibility, you're going to be doing great. So we're going to be covering Linux, and all the things that we cover here are going to be applicable to Red Hat. They're going to be applicable to Debian. They're going to be applicable to Mint and Ubuntu and so on. We're going to be going through all of them. So the first thing that we're going to hit is where stuff exists on a Linux and a Unix computer system. And for that, I actually want to go directly to my Kali system. There we go. And I'm just going to log in. I'm going to connect to my Windows system via the browser. We do some RDP shenanigans. Guac wants to do things. Sure, I'm going to allow it to get the stuff from my clipboard. It's kind of funny. A lot of students, when they do this, they say no. And they're like, copy and paste doesn't work. Well, it asked you. So I'm going to open up a Kali terminal. I'm going to accept. Oh, that's weird. This is my same Kali terminal from before. So I'm going to go ahead and I'm going to change my settings. We're going to go ahead and change the appearance. I'm going to change the font so you all can see it. I'm going to change it to bold, cool, crisp, and refreshing, just like the Rocky Mountains it comes from. There we go. So we set that. And we're going to start looking at some directories, right? So I'm going to do sudo su space minus, become root. And then I'm going to cd to the top level directory. All right. So if I'm working on a Linux computer system and I type ls at the top level directory, this is the beginning of the directory tree structure, right? All of these directories have a whole bunch of different files that we use for a variety of different reasons on a Linux and Unix computer system. For example, I have an intro labs folder. That's where I copied a bunch of my files over. You can see that one right there. We have a bin directory. Let's cd into bin, right? cd into bin directory. I type ls, and this is going to show me all the files that are in the bin directory. These are binary files, right? So if you're looking at this, all of these files that are green are binaries. They're actual executables that you can run on your Kali system. So we have like xhydra, we have xinit, xdm tools. My God, we got all of these TCP replay. So for the binaries that we would run on this computer system, these are, this is the directory where they would exist. Now I can change that. I can do ls -lrt, and I can get more information about what those files are. And you can see that most of these are owned by root, and that's because root installed them. But these are the binaries that we would use on our system. Now, some of these are symlinks. You can see right here, we've got some Python libraries that are symlinked over to another directory, but these are all binaries. Now, how does that relate to like your day-to-day usage on your computer system? So if you look at something called your $path, like so, that is your search path. By the S doesn't matter, it isn't search path. It's just a variable. So we call it path. And when you run a program like Echo, like I just did, it's going to search in the user local sbin directory, the user local bin, the user sbin, user bin, sbin, bin, snap, bin directories. So it's going to look in every single one of those directories for me to run the Echo command. If I want to know which directory it's going to execute from, I can do which Echo, like that. And it says, it's a built-in shell command. So I could try other commands. I could do which ls, like that. And it says it's aliased to ls, the color is auto. I can do which IP for the IP command. I can then do which ifconfig, like that. Oh, let's rerun that. Hold on, Control L, there we go. And it's going to say it's going to execute from the user sbin directory. So if I execute that program, it's going to execute it from that specific directory. All right. So let's go back to the top of the directory structure. And what else do we have? We have the boot directory. So if I go into the boot directory and I type ls, like so, these are all the different configs and versions of Linux that exist on my computer. This is actually kind of cool about Linux. So whenever you do an update to your operating system, You can do apt-get dist update or upgrade. You can upgrade your entire distribution, which is great. It's like switching from Windows 10 to a Windows 11 system, which you should never do. But when you upgrade your operating system on Linux, it keeps that original operating system kernel laying around. And when your Linux system starts, it loads up something called grub. It's just basically, it's a boot manager that you can choose which kernel to actually load. Now, the reason why this is so incredibly cool is because if you ever run into a problem where something doesn't work, you can simply go back to one previous version and then your stuff will work again. And then you can try to do the update in a different way so it doesn't break. This is really cool. This is a really neat feature of Linux and Unix where you can see the different versions of the kernels that we have in boot. So let me go back to the top level directory and let's cd into dev. Oh, this one's one of my favorites. Everything in Linux and Unix is a device. Everything. Sorry, let me clarify that. Everything in Linux and Unix is a file. Okay. Directories are a file with directory attributes. Files are files. Some files are executables. Some files are not. Some files are first in, first out device files. Some devices are also represented by files as well. For example, in my current terminal right now, I can type TTY, see if I'm a teletype terminal, and it says that I'm currently logged into dev PTS sudo teletype terminal 1. My terminal, the little thing that I'm typing into, is a device. And if I'm in the device file, I can see the CPU as a device. I can see different loops. I can see my hard drive as a device. I got a bunch of type terminals. I can cat out urandom. This is one of my favorite things to do. I can cat urandom like that. And it's just going to print random gibberish to my screen. Like literally, there is a device file on your Linux system that does nothing but generate random gibberish. That's it. That's all it does. I mean, how freaking crazy is that, right? And it just me dumping random gibberish to my system has completely broken my terminal at this point. I'm wondering what's wrong at this particular point. I wonder what I'm actually crashing out. What do you think? So this is one of the problems with Linux and Unix and Windows command line. You have people that are like, yeah, it's not working. Well, what's wrong? I don't know. It's not working. Do you have any idea, any guess at all as far as what do you think the problem might be? No, I got nothing. I've got nothing on that. I have no idea at all what's going on. Do you think maybe it's your putty session? Just throwing that out there. So by cutting out dev random, I completely blew up my putty session, which is awesome, by the way. I just love that, right? So, and for those of you that don't know, putty is the session that allows me to interact with my Kali system, right? So they're actually two separate computer systems doing two separate things, and we connect to the Kali system over an automatic putty session. So we literally broke it, but that is a device, right? That's a file that is a device that does nothing but print random gibberish. Memory is a device. You have network connections is a device. All of these things are device files that exist on your computer system as well. So awesome. Very cool. So let's go back to the top level directory. People are like, did you try Control C, which is like the command equivalent of turning it off and on again? Yes, I tried Command C. It was dead. It was not good. All right. So we got dev. Let's go into the etc. directory. All right. So whenever you're working with people that have never used Linux before, they kind of do things and say things that are a little weird. Like one of the things they'll say is like, yeah, man, I don't like Linux. I prefer Windows. I think Windows is easy and Linux is hard. Look, if you ever tell people that you think Windows is easy and Linux is hard, it proves two things about you. One, it proves you don't know very much about Linux at all, like whatsoever. The second thing it proves about you is you know even less about Windows. Right? Like the main reason why people seem to like Windows over Linux is because Windows has a GUI, right? And Linux does have GUIs, like a lot of the things have that as well. And that seems to be what people think. Like this is easier because there's a GUI. Trust me, The GUI in Windows is not your friend. Dealing with MMC snap-ins, dealing with different like Active Directory plugins is such a nightmare that most of the classes that you do for learning Windows Cloud Management, they just simply like, here's some PowerShell scripts that you can edit. So you can make changes via PowerShell, all right? Now, one of the things that makes Linux very, very, very cool is the etc. directory. The etc. directory gives you configurations for the programs that exist on your computer. Now, this seems a bit weird, but you'll have binaries in one directory, system or service binaries in another directory. You'll have configs and etc. So if I look inside of the etc. directory, these are all of the configs for pluggable authentication modules. PASSWD and Etsy Shadow are where my password hashes reside. My Java configuration, IPsec configuration, APG configurations, anything that you have on your Linux computer system that can be configured, you're going to be able to configure it generally in the etc. directory. There are people that try to move their configs into different directories, and I always say violence is never okay, and it's never the solution unless you can find the people that move their config files to non-etc. directories. It's just, you feel free to just slug bug those people, right? Now compare that to Windows. Where do you put configs in a Windows computer system? Like, where would you put a config in a Windows system, right? It could be in the directory of the program. It could be in internet users folders. It could be in a registry entry. It could be in a volume shadow copy. It could be in an alternate data stream. It could be in all of these different places, right? I've had people say it'll put it wherever it chooses to put that configuration. Thank you very much, right? So this is insane. Or INI files. Sometimes INI files are straight text. You can edit them. Sometimes they have binary data structures built into them and you can't edit them directly. It's bad, is what I'm saying, right? Whereas in Unix, the overwhelming majority of the configurations for the programs that you use are going to be in the etc. directory. There's one massive exception, and I'll get to that here in just a couple of seconds, but it actually makes sense if you think about it as well. So that's the etc. CD into home. Home is home, said the little frog. Home is the home directories of all of the users that have user accounts on the system. In your Kali system, there's one home directory for Kali because there's literally just a Kali user on this particular computer system. That's it, right? So that's the home directories on where people would be. All right. What else do we got? Lib. All right. Just so you know, it has nothing to do with politics. Like, you don't '90s that miss libraries because libraries are awesome, by the way. Uh-oh. We should be back. Anyone? Anyone? Are we back? Are we back on YouTube? Okay, we're back. We're back on YouTube. And I had like all my best jokes and you guys didn't get them at all. What's the last thing I talked about? Editors, we had a bit of a problem here. What's the last thing I talked about? Lib and politics. Oh my God, that's creepy. I start talking about politics and everything freezes. Scary. All right. So the lib directory has nothing to do with politics. Editors, we're going to fix that in post. Editors, we're going to fix that in post. So the lib directory has nothing to do with like lib or conservatives or owning the libs, right? It's about libraries. And literally, when you're thinking about this, I want you to think about libraries like old school libraries with like books and really creepy librarians, telling you to go shh, right? So if I'm trying to find a book, like let's say I want to find a book like Cats, right? If I'm trying to find a book like Cats, I can go to the card catalog system, pull that card out, and I could be like cats, cats and dogs, cats with hats, and so on. And I can find a book that has the relevant cat information that I'm looking for. And then it gives me a Dewey Decimal System, which basically says that library is over here at this particular section of the library. Your operating system works very similar to that. Your operating system, whenever it invokes libraries of functionality, it'll tell it what library of functionality it's incorporated in and what the offset is. And if it doesn't have that, it'll use like the dynamic linker to go and pull that library book and load that functionality in. So when you're looking at the lib directory, if I go into the lib directory, I can't type while I'm talking. I still get nervous, and then I type even worse, and then I get more nervous, and I'm like, I'm in a horrible nightmare. All right, so I'm in the lib directory. These are all libraries. Libraries of functionality for BetterCap, libraries of functionality for Mono, libraries of functionality for, what is it? libgdi plus, right? And we also have configuration directories for Wine, Xorg, UDev, TaskCell, systemd, SSL configurations. These are the libraries of functionalities that make these programs work properly on your computer system. So the libraries, 32-bit and 64-bit libraries as well. You have Lost and Found, which I don't think has anything in it right now. But let's go to media. Ooh, I hate media. All right, let me explain why I hate media. If you talk to people about Linux and Unix and you're like, why don't you use Unix and Linux? What would be the biggest reasons, the kind of the barrier points for people not to use Unix and Linux? Or just say Linux now, because it's not like, you know, it's kind of funny. I was reading a meme this morning and it was somebody that's like, Linux. Well, what the hell's Linux? It's a Unix-like file system. And someone goes, oh, it's like Unix. Like, it's not like that anymore. All of us old people, when you were trying to explain Linux, you'd have to say, it's like Unix, right? And it's like, oh, like Solaris. And it hasn't been that way in a long time. But if we're looking at like Linux-based systems versus Windows, you have support, of course, but think about the core applications that people use every day. What applications do we not have on Linux that exist on Windows that really keeps people from switching over to Linux? Think about it, right? Microsoft Office, right? Adobe tools, right? Games. So the only people that are making meaningful changes and kind of changing the ecosystem for Linux to be more compatible with Windows-based systems is Steam. Steam with Steam OS and trying to set up Steam client on Linux and using Proton, they can port Windows system applications like games over and have them run on Linux. And in many situations, they run faster on a Linux computer system than they do on a Windows computer system. In fact, you're starting to see a large number of online professional gamers that are moving to running Steam and Linux together because it runs better. So that's kind of a sea change. Things are kind of changing in the way that they do stuff. That's pretty cool. We still don't have Office Suite, even though Microsoft's going to move it all to the browser here anyway, and that's what I do. And then Adobe suite of tools. I'm still waiting for Adobe to get their stuff where it's available for sale on Steam, and then that's kind of it for Windows. Why the hell would you use that operating system? So really, we don't see as much movement as we should, but we are seeing some progression. But the Linux developers, they're dumb. I mean, they're really, really smart at some things, right? Like they're really, really, really good at some things, but they're really stupid at other things. And I mean that with a lot of love in my heart. I want to make that clear. An example, I'm good at hacking. I'm not good at hacking because I'm like a smart hacker. I'm very lucky. And in life, if you ever have an opportunity of being lucky or good, choose lucky. And I'm lucky. I've had times where shells have literally rained from the sky. I just kind of look at stuff and I'm like, oh, there's a hack. It's not like I'm brilliant or anything. I'm not. I'm a moron. I'm not very good at anything. In fact, I am so bad at spelling. This is not a joke. This is true. I am so bad at spelling that whenever I start spelling in Google for like Gmail, it's like, oh, your language is French. We're going to switch your language over to French because your spelling is that bad, right? It's really, really horrible. So whenever you're looking at Linux people, they're really smart people who are equal parts stupid. So when they're trying to get, let's say, people to start using Linux, they're like, you know what people need? They need a directory other than mount. Like mount is really, that's what's stopping grandmothers from using Linux. We need to, instead of using mount, we're going to create this directory called the media directory. We'll just have this media directory. And if somebody puts in a CD-ROM, it's going to show up in the media CD-ROM 0 directory. Like, what the hell? Like, out of all the things you could have done, you choose to create like a CD-ROM 0 or a media directory or ifconfig. I love ifconfig. I use ifconfig all the time. The fine people at Linux are like, no, we're not going to do it. We need to replace that with IPA. We're going to switch that out because this clearly is superior to ifconfig, right? It's just, you have these stupid things that developers do to try to make things easier, like the media directory, right? And that's just horrible. But media and mount are where things mount. If I mount a remote drive on a system like a Windows computer, which you will be doing in this class, by the way, it'll allow you to mount that remote drive, and it'll show up as a directory that's mounted under MNT, as God intended you to do. That's the mount directory. The next one is the opt directory. Now, opt is interesting. Opt is usually set up for programs that are completely self-contained. In many of these different directories, like Responder, John the Ripper, you have binaries, S binaries, you have lib directories, you have etc. directories, where they're basically packaging the entire tool together into one directory. And usually you see that show up in the opt directory. So you'll be doing this a lot here as well. All right. Proc. Oh, proc is one of my faves. We're going to be using proc heavily in the Linux lab that's coming up here in a little bit, but your proc file system does not exist on your hard drive. It doesn't. It actually exists at runtime. You see all of these numbers like 1086, 1096, 1108. Those are all process IDs. Those are all process IDs, okay? And those, whenever a process runs, it gets a randomly assigned process ID. The number, like the bigger or smaller process IDs, have nothing to do with how old or young that process is. You may have a process that's younger than another process with an older ID or higher number and one with a lower number. Don't look into it too much. So just going off of the process IDs, I can see all of the processes that exist on this computer system. And we're going to do more with this directory here a little bit later, which is kind of fun. We can cd into the root directory, which is root's home directory. See, I can't get into it. So if I go to sudo su space minus, I am now in the root directory. So I'm now in root's home. The only people that can go to root's home is root. That's it. All right. Now we're going to go into run, and we just have a bunch of different startup scripts for like things like SSH. And this kind of makes me frustrated. But you know, it's giving us process IDs for the different services that are running on the computer system. But sometimes they put configs in there, which is stupid. They shouldn't do that. sbin is the same thing as bin. But it's for system or service binaries. These are binaries that you would use to like do maintenance and do things on the actual system. Like you have IW list, that'll show you all of the different wireless networks, but I don't have a wireless interface on this. But it allows me to modify the wireless configurations. We have IW Spy, which is another wireless tool. KeyPass to John allows you to take KeyPass files and convert it to a format that John the Ripper can crack. But a lot of these are set up for messing with the actual operating system itself. These are system or service binaries on the computer. All right, so we're going to move into Snap. Snap is a package manager. One of my ranty things, I'm really not happy with Snap because it used to be that you would just kind of install things with RPMs. You could do RPM and install. And then they came up with APT and Debian, Advanced Packaging Tool. Then you have Snapped, and then you have Flatpak, and then you have apps. All of these different things, different ways of installing applications on a Linux system, which sucks. It really bothers me. I can't remember. There was a great graphic I saw of all the different package management tools for Linux, and there's like over a dozen that are commonly used that you would see run all the time. And that's just really frustrating. We should be installing things from source, RPM or APT, as God intended us to do. Snap is just a package manager. serve, we got services. You can see we got a TFTP server on this as well. Just different servers. Uh, sys for sys files. This, I don't know. All of this should be in lib or in sbin, but that's where they like to put some of the service files on this. User is interesting. Let me go to user. In user, you're going to have bin and sbin directories there as well. So an example of like a system or a service binary that should be accessible by a user is, imagine that I'm hosting a Quake server. Yes, that's still a thing that you can totally do on Linux and Unix. If I'm starting up a Quake server, I can start that server because it listens on a high unprivileged port. And I can start that as a standard user. No big deal, right? So I can do those service binaries. I can also have libraries and bins, and you can see that we have games. I don't think Kali has any games in it at all. Nope. But you can install games. You can install BSD games on your system. I can't remember what the package is called. Let's do... this is how you install packages. There we go. Now I'm installing games on my Linux system. Believe it or not, the BSD games that I'm installing, this exact command, you can install just about anything. If you're running anything, you can do apt-get install name of the program that you're looking for, and it'll go out online, find it, download it, and install it, which is awesome. But now I've installed BSD games on this, so what I'm going to do is I'll run trek. So, oh, do we not have trek? Did it not install? Uh-oh, that sucks. Bummer. Tetris? I don't think we have Tetris on this. So that sucks. I don't know why it didn't install the BSD games. I thought it did install the BSD games package. It didn't. But apt-get install installs games, and I don't think I have any in. Oh, there we go. So now we got all the games. So I have the package. It didn't install Trek. We have Snake. So that's fine. No, there it is. I just don't think it's in my path. There we go. Star Trek. This is the first game I ever played as a kid. So we go through, we do Trek. I hit return to continue. I want to do a short game. I'm going to say novice for the game. My password is John because that's what I did. So here I've got it in game. I just installed it with apt-get install BSD games. And I've got 5 Klingons, 3 star bases. I've got star bases at sector 740136. So I can do short range scan. This is my current quadrant. I can do our long range scan, and these are the different quadrants around me. The higher numbers are more likelihood of having Klingons. I've got a star base and things like that. All right. So at any rate, that's a game. I can't remember how to quit. I think I have to self-destruct. All right. Control C, kill it. There we go. Now we're out. So yeah, I just installed the game. There we go. The games directory didn't have anything, and I wanted games. I've got games. You can do backgammon, Battlestar. That's pretty cool. You got cribbage, all of those. That's fun. So yeah, the games directory has games. So for those of you that don't know, kids, this is literally like, that was like the bomb in the early 80s whenever I first got my first computer. I was working on it. So we got into the user games directory. var is for variable directories. Now, it used to be with hard drives on systems, you had spinning hard drives, right? And those spinning hard drives would have a mean time between failure. And the more you wrote to a hard drive, the more likely it would be that hard drive would fail. And you wanted to set up a situation where you could have your variable log files being written continuously to a hard drive, but done in such a way that if the hard drive failed, it wouldn't crash the entire system. So you would basically create your var directory that had variable files, and you could mount a separate hard drive for your logs. So if that hard drive failed, it wouldn't be to a catastrophic collapse of the entire system across the board. So you'll have things like log files in here. So if I go into the var, I have the log directory. I can see all of the different logs that exist on this system. So that is kind of a quick overview of the directory structure of a Linux computer system. Now, I've been playing around with some of the privileges. You saw me, I couldn't go into root's directory, home directory, because I just didn't have permission, right? I had to be root. So I ran sudo space su space minus, and then I put in the password for my user account for Kali, and then I'm able to become root. And what that command means is switch user and do a command. And in this situation, it means switch user, do the command su, which means switch user minus basically means we're going to become root with all the environmental variables thereof as well. There's multiple ways. You can just do su minus. You can do sudo su space minus. There's a number of ways to become root on a Linux computer system. All right. Home directories. I talked about home directories a little bit. Let's revisit that because I think that that's kind of important. So I'm going to cd into home Kali. Now, I told you that the majority of your configs are going to show up in the etc directory. But I said that there was a whole bunch of other configs that are not in the etc directory that are incredibly important. See any of those config files there. So if I do ls, I see nothing. I do ls-lrt, I don't see my config files. But watch what happens when I show a, which allows me to show quote unquote hidden files. If I do ls minus lrt a, now I'm going to see all the files that begin with a dot. These are am I gone again? Can anyone hear me? Let's do a quick status check. All right, we're good. Editors, we had a little glitch in the matrix. Maybe we're back. All right, so you see all these files that have a dot in front of them? These are hidden files. These are hidden files, not hidden like they're malware per se. But these are files that are suppressed that have my SSH config. They have my Metasploit configuration. They have my VNC configuration. They have my GNU PGP key configuration and so on. They are suppressed because I do not want to see them all the time. I want to know that they're there. I want to be able to get to them, but I don't want to have to deal with them every time I go to this directory because it clutters things. So when I do A, it allows me to see these quote unquote hidden files. And once again, hidden doesn't mean malicious at all. If I wish to make a directory, I just do make dir. Same in Windows, same as Linux. If I want to find a file, I can use locate. So I can do ls, locate ls. I will find every single file on the system that has ls in it. I can also do locate, let's say config. Find all my config files. I can locate john.pot. So this is the file where I put my cracked password hashes from John the Ripper, and I can find these files, right? Now, every once in a while, you need to update this with the command update db, and it'll go through and re-index the entire file system on your operating system as well. Now, we're going to be using VI, like if you're with me for the next 3 classes, we do use VI heavily, all right? And VI is like, it's a text editor, and once again, it's one of those things where people get completely worked up about what is their favorite text editor. So let's say hypothetically, I were to ask a bunch of people what their favorite text editor was, and those people were on Discord, right? Hypothetically speaking. And I start asking them, I'm going to get like Vim, I'm going to get Nano, I'm going to get Pico, I'm going to get Kate. You'll have somebody eventually that's going to say Set and Awk is going to be their favorite editor. And those people are just wrong in the head. And once again, this makes people freak out a little bit. If you're trying to learn Linux and Unix, start by learning VI or Vim. Start by learning VI or Vim. The reason why is it's always there for you. You may not have Nano, you may not have Emacs, and these are all different types of text editors. And I've given you a quick little, just quick cheat sheet on how to run VI. If you're in VI, you hit A to start editing, you hit escape to stop editing, and then you hit like Shift:\WQ to write and quit. All right. Easy, easy, easy to use. However, if you're trying to make life a little easier on yourselves, you can use Nano. One of the cool things about Nano, excuse me, that's really cool about Nano is at the bottom, you can see all these caret commands. Like look over here. You have caret, oh, that's write out. Caret W, where is? Caret slash, replace. You have kind of built-in usage information for how to interact with Nano. You even have the capability, caret T, to do spelling and things like that as well. So very, very, very cool. Processes with Linux, you could use the PS command. It shows you all of the processes. Now, one of the things you're going to learn on Linux is there's more than one way to do the exact same thing. And that's okay, right? That is okay. If you have multiple ways of looking at processes, it's perfectly fine. You just can go do that however you want, right? But now I'm listing out all the processes on my system. And with the command, you have PSAUX is all processes sorted by user, including the one associated with teletype terminals. You also have top, and there's multiple different really cool versions of top that have like color codes and all kinds of cool things. But just straight old top gives me kind of a running accounting of what is happening on my system right now, and it updates, right? So it's kind of like Task Manager for Windows. I can see all the processes that are running on my computer system, how much memory they're using, how much CPU you're using, and it'll show me like what is the current status. And it updates like once every 3 seconds, I believe. So with top, beautiful, easy to use. There's other versions of top that have like cool colors and stuff. I just stick with old school top. It gets me what I need. Now, when you're done with top, hit Q and you'll break out of top. There we go. Getting information, I already showed you IP addresses. IPA, it has nothing to do with the India Pale Ale. It's not a beer. No, people are like, oh, it's an IPA. No, it's IP space A. It's IP. We're getting adapter information for IP addresses. It has nothing to do with beer. And like the number of people that just look totally disappointed when they realize that it has nothing to do with beer is interesting. So there you go. I use ifconfig, and probably until the day I die, I will install, traditional tools and just use ifconfig on my system because I'm old and I'm stubborn. I'm like that guy that lived right below Mount St. Helens in the lake, on the lake. And people are like, dude, you got to move. And he's like, I ain't going anywhere. I've been born and raised in this cabin and ain't nothing going to move me. And boom, like that's going to be me with using ifconfig. Ping. Oh, ping. Does anybody know what ping stands for? Like, if you want to look it up, go for it. But the name of ping is kind of interesting, right? So some people know it stands for Packet Internet Groper. Literally, there's a tool that has groper in the name. And it's always interesting to me because we have people in IT, they're like, you know what we need? We need more women in IT. We need more diversity. We just need, I don't know why more women aren't in IT. And we literally have a tool that's called the groper. Like, it seems to me like if you're a woman coming into IT and they're like, all right, everyone, grab your packet groper, you'd be like, excuse me, what? Yeah. So I had a whole bunch of jokes associated with the packet internet groper. And I'm not making this up. This absolutely freaking happened, even though most of my stories are completely made up or heavily shaded. I had a whole bunch of jokes talking about who the hell came up with something called the packet internet groper, what was wrong with this person. And after I got done teaching a class with SANS years and years and years ago, I had somebody that sent me an anonymous email and they said, hey, you spent a lot of time ripping on the person that wrote the packet internet groper. And I think you need to know that he was a family friend of mine. He worked with my father at X and X Labs organization, and he wrote the tool for the packet internet groper. And he was such a quiet young man. who kept to himself mainly. And as he starts describing this person, I'm like, you are literally giving me the exact same description as a serial killer. So not helping, not helping. And by the way, thank you for the new joke. I greatly appreciate it. So people like sometimes wonder, it's like John's stories are made up. A lot of them are actually. And the reason why is if I were to tell you a story, let's talk about hacking stories in particular, is if I were to tell you a story like, okay, we were doing work for a Fortune 1 company and we found X, Y, and Z vulnerabilities, you'd be like, wait a minute, that's Walmart. You know, so a lot of my stories, if I say it's a medical company, it could be a finance company, it could be DoD, it could be any of these different things. So I slightly change the scenarios, even though the thing happened, the surrounding circumstances, they just didn't. Now, Bill absolutely happened, the one I talked about yesterday. But his name wasn't Bill. See, I changed it to protect Bill. The other thing that I didn't tell you is Bill was actually an intern. He still looked like he was 95 years old, though. All right. If we want to identify what ports are open, we can use the network mapper, right? Nmap. This is a tool written by Gordon or Theodore. It honestly, I think it is without question it's the second longest lived, commonly used security tool to date. The only tool that's older than this, I would say, that we still use regularly is Netcat. So it's a really cool tool. Like we talked about those ports, 65,536 ports. Nmap is the tool that helps you identify which of those ports are open on that system. I mentioned the idea of ping port parse. If you know how to ping port parse, the whole IT world is your oyster, right? So ping, can I ping the system? Is it alive? If you spend hours trying to get connectivity working with the system and it ain't working, check to see if it's turned on and plugged in. That's a really good first step. Port. Is the port I'm trying to talk to actually open? Do I have a firewall? Is the service itself actually running? Ping, port, and then parse. Any error messages, any logs that are generated, start parsing through the logs whenever you attempt to make those connections, and you're going to be fine. Because a lot of times the errors, the logs, they will give you exact details as far as what the problem actually is, right? Network connections, number of ways to show network connections. Well, we can run netstat, which is very similar to Windows. We're going to talk about Windows after we're done with the Linux system, but we can run netstat to look at network statistics. I don't use that on Linux. I just don't. My personal favorite one is LSOF. Ooh, this one's good. I like LSOF. Why do I like LSOF? So everything on Linux and Unix is a file. Right? I mentioned this. Everything is a file. So if I have a tool that gives me the ability to list all of the open files on my system, this is literally telling me everything that is happening on my system right now. And that's powerful. So what you can do is you can change the parameters of LSOF. So I can do LSOF and I can go, I want to see just the files associated with open internet connections. So now I can see DH client is running, container, SSH, VNC, and SSHD are running. These are my open and listening services and the outbound client connections. Now, do you see on the right where it says boot PC, Kali DHCP, SSH, X11? I can change that. I can change that by doing a -P, and it won't try to tell me what that service is, and it'll switch it to just giving me the port number associated with it. But wait, there's more. In here, I can see I have, nope, here we go. Now we're back. I'm good on Zoom. Nope, here we go. Now we're back. I'm good on Zoom. I don't know what's going on. It seems like Zoom is doing good, but everything else has kind of got a little wonky. I'm just going to tell you, though, we are entering construction season, right? I mean, we're entering the time of backhoes. Okay. All right. So if I can see all of these open internet connections, it makes it very powerful for me to see what is going on. And I can even drop in to what the individual files are being used by an individual process as well. So here you go. Now, the other thing that you can do is we can kind of tie some of this stuff together. And we're going to do this in a lab here in just a couple of minutes, where if I know a process ID, I can go into the proc directory, then that process ID. So an example would be, let's say I'm in the proc directory and I know that I have a process ID of 360 that is interesting to me. I can drill into what is accessible in the memory of that system. In particular, I can get interest in the exe file, right? So I can do strings against that executable while it's running, and it'll give me like, what is that executable? Like it'll print out all the human readable printable strings. Finally, we have bash history. This is an accounting entry of all the commands that I've ran at the command prompt as well. So this brings us up to the lab. I'm going to go ahead and move into intro labs, and we're going to enter the Linux command line lab. Now, this is great question I get from people from time to time, and I completely spaced it. If I do my history like that, it shows me my history. That's cool. If I run a command like ID and I run history, you can see it shows up in my history. But if I do space ID and space who am I, like that, and then I run history, it doesn't log those commands in my history. A little bit weird, right? That's a little bit strange. I don't know why that exists. It's existed for a long time. For the life of me, I cannot understand why anybody would ever do this as well. Also, now that we have a little bit of connectivity, I can go into the proc directory. I can go into proc. We can choose a directory. Let's go to 16.2.1. And I can do strings against exe. And pipe that through less. And we can start learning like, what is this particular command? So you're seeing like, these are the errors associated with it. We've got the libraries that this particular process is using. So it's giving us a lot of really cool information, error removing orphan signature, all kinds of different things that we have with this. This looks like it's the evolution process on this system. I'm not sure. So pretty cool being able to go in and look at the strings for quick and dirty, forensics analysis on this system. And that's what we're focusing on, right? When we get into the Linux command line, we are going to focus on what is it you absolutely need to know on a Linux command line to do that quick based triage on a Linux computer system. So for this lab, we're going to have 3 separate command terminals. We're going to have terminal 1, we're going to run a backdoor. Terminal 2, we're going to connect to that backdoor. Terminal 3, we're going to analyze that backdoor on that as well. We're going to go through and set it up and walk through all of those. So we're going to go ahead and set up our Kali system. We're going to become root, and then we're going to be playing with backpipes. All right. So when you're going through this stuff, there's a lot of information that we're giving you, and it can be very overwhelming to start. Couple of things. These labs exist in perpetuity for you. Number 2, you have access to the recordings of this class. So you can keep coming back to it again and again, because the only way you get good at anything is through repetition. Why do we fall down, Mr. Bruce? We fall down so that we learn how to get back up, right? So we're trying to make this accessible because, whenever I was teaching for a previous organization, people would charge like $10,000 for a class, and the people would show up and you'd have 1 week, they would get overwhelmed and they would start panicking. I have literally had men and women in uniform cry during my classes. Actually, that story, I went out, I was teaching at the NSA headquarters out in Baltimore, and it was we took a 6-day class. We're going to run it in 5 days. My plane got delayed. So they said, dude, just teach the class in 4 days. That's not a problem for me. I'm like a tickle me Elmo. You just pull the string on my back and just computer security facts are just going to come spewing out. In fact, honestly, I'm not even really here mentally at all. I'm actually asleep in the back of my head. I'm not joking. My watch whenever I'm teaching, my watch sometimes switches and says, you're sleeping now. Like my heart rate goes down into the low 50s and 40s. It's kind of creepy. So I understand that this stuff can be a little bit overwhelming, right? And instead of running these classes, like, especially these introductory classes, and running them like once and charging hundreds, if not thousands of dollars for it. That's why it's pay what you can. That's why it's recorded. That's why everything is free and it stays available for you to keep practicing until you get this stuff straight. All right. So we're here for you. All right. So I'm telling you all that because I'm going to just throw out that this next part is weird, right? So we're going to be using a backpipe to create a backdoor. Now, I'm not going to try to sugarcoat it. Backpipe is kind of crazy. I'm going to walk through after the break and explain what is going on with the backpipe. It's a different type of device file. It's a first in, first out file, which really doesn't help those of you that have no idea what that is. But I'm going to explain it. Just know that this creates a backdoor, and I'll walk through it after we get done with the break and the lab as well. Then we're going to run ifconfig, get our Linux IP address. Then we're going to netcat from our second terminal into your system, and we're going to run a few commands. Right? Then we're going to open up another terminal that's going to start doing the hunting. We're going to become root, and we're going to start with LSOF. We're going to do LSOF. Then we're going to drill in on the process ID that is of interest to you. Then we're going to go into that directory and proc. And then we're going to run strings analysis against that executable until we can find out what exactly that malware actually is. All right. So that is it. So this is the lab we're doing, Linux command line. Now, as I mentioned, this lab is going to take us up to and through the break. I am going to resume. We're going to have a 10-minute break, 30 minutes for this lab. This is a long lab for people. So we will resume at 40 after, or 20 till, depending on your perspective, half empty, half full, however you want to look at it. So we will resume in about, I think we'll give it like 43 minutes. So it's nice endpoints. So with that, let's get rolling on the lab. If you need any help, please hit us up in tech support. Who's ready to do some labs? Let's do this. All right. So as I mentioned, we're going to have, 3 terminals set up at the exact same time. So I got one here. I'm going to open up number 2 and I'm going to open up number 3 and I'm going to kind of stack them like so I can zoom in on them like this. And we're going to kind of set them up so we can easily get our malware going. And then we're going to save the big window that I have. That window is going to be used for our hunt. All right. So the first thing that I'm going to do is I'm going to become root, and then I'm going to create something called a FIFO device file, not a FIFO device file, but a FIFO device file. And that particular file, how it actually works is I told you that everything in Linux and Unix is a file. And if we paste in this particular command, what this particular command is doing is it's creating a file, a special device file. The P denotes that it's first in, first out, and then backpipe is the name. So I could have called it make node bill P. That would have created a file called bill that was a FIFO device file. Now, the reason why you would create a backpipe is so programs and applications and services can talk to each other and transfer data and not have to open up a network connection to do so. All right. So a way to think of this is if you go to a hotel and you go to a conference center, in many hotel conference centers, you have all of these big monstrous rooms, you have hallways where people are walking around. And the vast majority of the work that's actually happening to support the conference center is kind of hidden, right? You have like these hidden hallways, hidden corridors, hidden kitchens behind the actual convention center. So whenever you're looking at this, you could also think of it as like a haunted house with haunted corridors. What we're doing is we're creating a back-end corridor so we can communicate back and forth without having to open up a network connection. So we're transferring data, but we're transferring the data in the form of a file rather than actually having a network connection. So we called that file backpipe. And you could have named it anything. The P denotes it as a backpipe file. So now we're going to do bin bash, and we're going to do some really weird stuff with that backpipe. All right. So remember, the ultimate goal of what we're trying to do here is we are trying to transfer data between multiple processes, but we're transferring that data across these processes utilizing backpipe as that hidden backdoor. So let's dive in to kind of cover what exactly is going on. So the first thing that you see in this command is bin bash. That is literally our bash command prompt. That is how we communicate to our system. As a hacker, you'll see things like I love shells or I heart shells. Shells are awesome. Shells are wonderful. Shells are great. That allows an attacker to talk to a computer system. In this particular scenario, the shell that we're utilizing is named bash, bin bash. Then we encounter a backpipe. That first backpipe that you see on the left is actually going to be ignored to start. I'll explain why here in just a couple of seconds, but we have that data that's going to be going into a backpipe. Then we get to the second backpipe, and this particular backpipe is you got that 0, and then you got the little gobbledygook like alligator mouth, and then the backpipe. What that is saying is it's saying take the data from backpipe and load it into standard input. And the arrow that it's pointing says it's going to put it into the input of the bash command prompt. Now, just to be clear, like if you're looking at all of this and you're kind of freaking out, don't worry. It took 3 of the smartest Unix people I know, George Bakos, Chris Brenton, and Bill Stearns, an entire weekend and a lot of beer to come up with this. So if this is a little bit confusing, please don't take it as, well, this is pretty much noob level stuff. This is pretty complicated what's going on under the hood. The big thing that you need to know is we're creating a backdoor that listens on port 2222. So then we take any of the data that we received from our command. In this situation, it would be bash because it's going that particular direction. And it'll put it into the netcat listener, which is listening on port 2222. Any data that is connected in port 2222, if I type ls, it's going to get into standard output, which is a 1, put into the backpipe. Now, when you and I, or most of us on this webcast, when we read, we look at everything from left to right, top to bottom. Okay. So the real kind of focus that most people, when they're reading this, they try to read it as a line of text that goes from left to right. And in this particular situation, I don't have 3 backpipes. In this particular situation, I'm referencing the exact same backpipe every single time. Okay. I know that that seems weird, but that backpipe is a file that we're loading data into. And as soon as we load that data into it, it's going to redirect that data to where we want it to go. So we have bin bash, we have our backpipe that is going to receive the output with a value of 1 from our netcat listener on port 2222, puts that into backpipe, and then it's automatically, as soon as that data gets into it, it's going to try to kick it into standard input into bin bash. So don't think of it as flowing from left to right. I instead want you to look at it as where the arrows exist. So I'm going to start this up right here. It's kind of like a defined variable, but it's actually a file that is loading that data. So I hit enter on this one. And now our backpipe backdoor is listening. Now on our second terminal down here, if I can get there, there we go. I'm going to make a connection to that right here. So we're going to go ahead and we are going to make a connection. So we're going to go netcat to 127.0.0.1 on port 2222, like so. We hit enter, we've connected. So if I type ls, it gives me the files. If I do ID, it gives me who I am. So in this situation, I list the files. The file was backpipe. ID shows that I am logged in as root on this system. So as I said, this is kind of complicated. Just so you know, you do not have to know this inside out and backwards, but I'm just going to kind of walk through. The big thing that you got to do is understand that whenever an arrow is pointing the wrong direction, it's ignoring it. So if we receive data out of bin bash, we see that that one backpipe is shoving it into standard input. It's just going to ignore it. But when the data comes in our netcat command, like I ran ls, it's going to put it into backpipe, and then it's going to put it into standard input, which executes it in bash. Like I said, confusing, understandable, understand that for sure. It actually took me months to finally get to the point where I understood this. But this is what we call a one-liner backdoor. It's a simple one-liner backdoor. So some people would ask, would an SSH connection perform the exact same function? Absolutely. Absolutely, it would. However, if we log it into, let's say, SSH, in that particular situation, there would be a log of that connection. The other thing that's really neat about this is Bash and Netcat tend to exist on all Unix systems. So you can embed this inside of your malware and execute this command. So it's very small and it's a very tight-knit backdoor. So now on my Linux computer system, I have a backdoor that's running on this computer system. So now what I want to do is I want to hunt said backdoor, because that's the primary goal of what we're doing here, is we want to start hunting that backdoor on our Linux computer system. So we've got our connections. I've ran some commands. Let's go hunting. The first thing we're going to do is we're going to run lsof -i -P. So I'm going to copy that and I'm going to paste that in here. What does that command do? LSOF is list open files. With a -i, it means I want to see the open internet connections or iNet connections. And then the P means don't try to resolve the port number to what the service is. I just want you to give me the port number. I want the straight dope. And down here at the bottom, you can see that we have our netcat listener, which conveniently enough says, listen, Lisa, listen. As you can see, it's listening on port 2222. And that is our netcat executable. Now we also have netcat connections here as well. We have both parts of our backed pipe here, but I want to focus in on this one right here. All right. So if I was doing an investigation on this particular computer system, trying to figure out what exactly is going on, I would see that I have a listening connection, or I would have an outbound connection, something like that. And I would start investigating that process ID. To investigate that process ID, I would do LSOF -P, lowercase p, and then I put in that process ID of 4274. 4274. And now I'm going to see all the open files associated with that executable. Now, the reason why I'm doing this is I am investigating that process. Now, we know we set up the process. We know it's netcat. We know we created a backdoor. But in the real world, you would have to investigate potentially malicious processes on your own. This methodology would be applicable to this lab, of course, but then any potential Linux executable that you're investigating as well. So here we've got netcat. We've got it, the root is root, the top level directory is the top level directory. You can see that the binary that's executing is user bin nc, and then you can see the variety of libraries that it's invoking with it as well. So we've got all of that from this one command, but we can go further. If I do not know what this executable is, right? If I have absolutely no idea what this executable does on this particular computer system, I can start investigating that process ID by looking in the proc directory for that proc process ID. So I can cd into proc and then the process ID of our netcat listener. When I type ls, you can see I've got a number of different files and directories here, but the main one that we're going to focus on right now is exe. Exe is the executable as it resides in memory on this computer system. And I can kind of walk through why that's important here in a couple of seconds, but I want to investigate that executable. Now, I could go get Ghidra. I could go get IDA Pro. I could start doing all kinds of debugging techniques. I could do all kinds of amazing high-end kung fu to try to investigate what that executable is. I could do that, but I'm not, because I'm lazy. Instead, what I'm going to do is I'm going to run strings against that executable to try to get some printable information about what that executable is. So I can do strings like this, and now I'm going to run it against that executable, and I'm going to pipe it through less because I'm lazy and this is quick. So right off the bat, I can see that we have a bunch of libraries. I can see C functions that are referenced in here. So far, so good. I know the program's written in C. Am I right? Yeah. Okay. But if I keep going, this isn't telling me what the executable itself actually is. Eventually, I'll start seeing some error messages in this executable in memory. Write error, create Unix socket failed, Unix connection abandoned. Well, that now seems kind of bad. This particular thing has the ability to make network connections on that as well. So we're going through set TCP received buffer size. We have all of these different things. Oh my gosh. What is we got? TCP send password, MD5 digest. Wait. What's this? What's this? It says OpenBSD Netcat Debian patch level 1.187 Ubuntu usage information. It uses IPv4, uses IPv6, connection information, all of it. So now I know exactly what this executable does. I know exactly what its capabilities are. I literally have the man page for Netcat. So we may have questions about this, right? Like in theory, a SOC analyst is going to attempt to investigate this, but they need permission to run these commands. So if they don't have permission to run these commands over these, they can't run them. What would you do in that situation? It's not a technical problem, right? If we have something like that, that's politics, right? That gets into how your SOC, how your MSP is set up. Most MSPs, if they're investigating a system, they will have access to that system. If you're a SOC analyst, many times you'll be getting some telemetry off of those computer systems and you'll be pulled into an incident. Now, if you're thinking about a general right out of college SOC analyst, you're probably not going to be doing this at all. And I would have people that would then say, well, if they're not going to do this, why am I going to learn it? Excellent question. The answer to that question is if that SOC analyst wishes to stay a level 1 SOC analyst for the rest of their life, they don't ever have to learn this, right? You can just get an alert from an EDR, you can process the alert, and you can send it up to the customer. But a good SOC analyst will know how to do these things. In our SOC, our customers, if we get an alert like this, either A, we would do an immediate investigation. Our product that we use for gaining access to systems, we can actually run commands. In fact, a little bit later, we're going to be doing a lab with Velociraptor where you can execute commands on multiple systems and pull that data back to do analysis. Or the other thing you can do is send the command to your customer and have them send that response back to you. Either way, this absolutely needs to be something that there is a skill set in every single SOC analyst that has the capability and the understanding how to run these particular commands to hunt these things down. All right, you guys want to see some cool stuff? I don't know if you guys like cool things or not. All right, okay. Some people like cool stuff. All right, let's do some cool stuff, right? So I'm going to cd to the top level directory and I'm going to do which nc, right? So what we're going to do is we're going to copy that version of Netcat to /not evil. Okay. So now I have not evil in that directory. So I have an actual version of Netcat that is listening and running on this particular computer system in that specific directory, right? So let's say that an attacker does this exact same command. Let me kill this real quick. They create this backdoor, but instead of them using Netcat, they're going to use, come on, arrows. Oops. Everything got a little weird there. There we go. Make that bigger. There we go. There we go. So instead of running Netcat in this particular directory, we're going to run not evil.exe, and it's listening on port 2222. All right. So we did the exact same thing, right? We have the malware running. It's running in memory. We just have a different executable. And I can still make a connection to that executable as well. And then I still have access to that system. All right. Except my binary is not evil.exe. Now, my attacker is pretty smart, right? So the one thing that this attacker is going to do is they're going to go RM and they're going to run it against not evil. And they're going to absolutely delete their binary, their backdoor that they created. So now if I run ls, I only see backpipe. I no longer see not evil because not evil has been deleted from the computer system. And yet my malware works just fine. All right. Malware is executing, no muss, no fuss. We got it. But the actual executable itself has been deleted. So now I'm a forensics investigator. I see some weird things happening on this computer system. So if I do ls in that directory, there is no not evil executable at all. It's gone. All right. So if I want to hunt down these particular files, I can find them in a couple of different ways using the lsof command. So I can do lsof and I can search for files. This is a weird command. This is list open files and the plus means include. And then if I do L1, it says include the files with a link count less than 1. And in this particular situation, I can see that notevil.exe is a deleted executable. I can run lsof -i minus capital P, and I can see that I still have my not evil executable is here. But if I try to investigate this process ID, this 4700, you can see not evil.exe is there, but honestly, the actual executable itself is gone. Like I can't go to that directory and I can't investigate notevil.exe because it's been done deleted from me, and that's a problem. All right. But it's actually not that big of a deal. The reason why it's not that big of a deal is because of the technique that we went through. You can actually pull it out. So I can do cd proc, oops, into the 4700 directory. And then I can copy the exe file to temp like that. And now I've pulled that executable out of memory, right? I'm pulling that executable out of memory and I'm dropping it into the temp directory. So now I cd into temp. We can see that executable. And it's our netcat executable. So this particular technique that we just went through, it allows us to not just find malicious executables on a file system, but it also allows us to extract those executables if they've been deleted from the Linux computer system as well. So this whole thing works if we have evil, but it also works if the evil has been deleted, and it is residing in memory. So we can pull memory resident executables out of memory as well. So pretty cool, right? So this is a lot of fun. Hopefully you enjoyed this lab. Good times were had by all. There we go. All right, so let's get going. So we're going to start by talking about Windows, and we're going to end today with another long lab, just like we did from Linux, but we're going to spend time going through the exact same type of process that we did on our Linux computer system with our Windows computer system. Now, these Windows commands are all commands that you should know and love. Some of them are going to be retired eventually in newer versions of Windows. But just for the record, they're still useful because not everything is up to date on the newest version, but there's multiple ways to answer the exact same question on a Windows computer system. Now, when you're starting with the Windows computer system, it's essential that you start by looking at network connections. And the reason why I recommend starting with network connections is, well, let me just show you. So if we go back over to our VM and go like that, and I'm going to close out my Linux VM here. I don't need that. I don't need that. I don't need that. And we just start with some of the basics on a Windows computer system. If I run, let's say, a task list, I'm going to get a list of all the services that are running on this particular Windows computer system. Oh my God. What absolute complete garbage this is as a starting point to investigate looking for malware. It's almost like people are trying to find executables called evil.exe, right? Like, oh, I think I found the problem. What is it? Satan. It's like, oh, it's Satan.exe. It doesn't work that way. Or they hit Control-Alt-Delete and they start looking at processes and they just start killing processes, which is just no way to live. You just shouldn't do that at all. Instead, we're going to start with network connections. Now, when you first look at network connections and what we show you on network connections, it's going to kind of freak you out a little bit. For example, on this particular situation, if I do netstat, like that, oh, like that, I still have a lot of network connections that are here. And yeah, this kind of looks scary. I can make it look scarier, right? But believe it or not, this is much better. but we're going to show you how to look for the right thing on the data that you're receiving. So we need to start by looking at these network connections, but on Windows, we can look at network connections in a wide variety of different ways. One, we can look at them as raw network connections with netstat. The other thing we can do is we can look at it through the perspective of open shares. Are there any open Windows sessions, SMB sessions, between multiple Windows computer systems by looking at net use and net session? And that is exactly what we're going to be doing. So NetView is the one we're going to start with. We're going to start by looking at the shares on a Windows computer system. And the reason why we would use NetView, and I don't think I have any shares mounted on this system, but if I did this, right? I don't have any entries on this list, but if I have an attacker that's compromised this particular computer system, they'll look at this computer system as a beachhead. This becomes the system as they move laterally around the environment where they will start moving share data or data onto that share so it can be used as a launch pad to exfiltrate the data out of that environment. Now, shares in and of themselves doesn't mean it's evil. You have to ask yourself the question, is it normal? Are these processes and these shares normal? And that requires us doing some level of baselining to start when we're doing an investigation on this. The next one would be net session. All right. So when you're looking at a Windows computer system, let's say I'm that system, right? So I'm that computer, I'm miming being a computer. It's like I'm stuck in a box. It's a Windows box. It's a Windows 11 box. Oh no. All right. So I am this Windows computer. I can have a system connecting into me, right? I can also make outbound connections from me. We have two separate commands on Windows where we can look at what the inbound sessions are on that particular computer system, and we can look at what the outbound connections are for that particular computer system. Because you very rarely look at an incident as an isolated workstation that isn't communicating to domain controllers and isn't pivoting to other workstations. Attacks are often in a chain, all right? So the first one is, who is this current system talking to? So if I do this, let me just do this. Let me go net use star. Let's go 127.0.0.1 C dollar. All right. So I can make a share on this. So now I have drive Z. Now I've made an outbound connection to myself from myself. I know that that's kind of cheating, but you get the idea. So net use, what it means is net use, we're going to mount a share on a Windows computer system. Star means the next available drive letters counting backwards from Z, Z, Y, X, and so on. And I'm mounting a connection onto 127.0.0.1 on the C drive. So if I go Z colon, oops, there we go. If I do Z colon like that, Z colon, I now have a C drive mount on the C share. All right. So I can go back to my C drive and so on, right? And I can run different commands. Now I can run net use like this, and it'll say the Z drive is mounted. Once again, I don't know why I'm thinking like Top Secret with Val Kilmer. Val Kilmer passed away at last week, and I'm kind of sad about that. But how do we know you are not Mel Torme? But all right, I have Z drive is mounted, and I can see if that drive is actually mounted with just the net use command. We can see that we do have a Z drive that is mounted on that computer. The next one is net stat. Net session and net use. Let's see if we got both of those. Let me zoom in. So we got net session. All right. You can see that I have an inbound connection made to this computer system, and the person's logged in as administrator, and net use tells me what drive I have mounted on the system as well. So we've got that. Easy peasy to look at those connections. The next one that we want to look at is, there we go. We want to look at net stat. This is going to show us all connections, right? This is going to show us every single connection that's going on and running and doing all of this stuff. It's not really going to get into, is it an SMB share? Is it not an SMB share? So once again, a different use case. Once again, being able to ask multiple different questions in multiple different ways is absolutely essential for us to be effective in trying to deal with attackers on our computer system. And NetStat by itself, garbage, like just hot, stinky, smelly garbage. Let me show you why. So let's go ahead and let's zoom in. Let's do netstat. All one word. There we go. Whew, that doesn't do a lot of good. We have a local address. I can see that that's terminal services because I know my ports, 3389, right? We talked about that. That's an important port. And then I have one connection on port 445, 6789, 6789. And they're actually all making connections back to myself. This doesn't tell me a whole lot, right? I don't know what the process is. I can infer the process is terminal service, but these other ones like 445, 6789, 6789, 6789, 6791, this 49971, I don't know what these are, right? This netstat command is awful. Why am we spending time looking at the netstat command? Well, it turns out we can make this netstat command much better, right? We can take this netstat command and we can run it with the switches NAOB. So N is going to display all active TCP connections, right? And we're going to look at A, we're going to look at active TCP and UDP connections. And then O is going to give us the actual process ID that is responsible for that connection. And B is chef's kiss. Chef's kiss is the actual executable associated with it. Let's look at it now. All right, so if I take that netstat command, I'm going to clear my screen. We'll go netstat minus NAOB like that. Oh, that's a lot of data. That's a lot of data, but it's good data. All right, so what is so awesome about this data? Well, I can now look at what these different listening services are. I can get their process IDs, and I can also get the name of the executable that is running on this system, right? All of a sudden, we're at the point where we're off to the races. We can now start doing good investigations on our computer systems. We would want to focus on anything that is established. Right here, you can see I have established connections via terminal service. That's my GUI session. Right now, that's me looking at me. Hi, me. Yeah, I've got that. Hello, me. It's me again. All right, there I am. Pretty cool. I also have a number of different Elastic Agent connections that I was talking about. I was like, what are these? You know, the 6789, 6789. I can see that that is Elastic Agent. All right. So now I'm answering these questions. That's very powerful. If we can start here with the network connections and we can start working backwards off of these network connections, it really makes the universe a lot smaller and easier to digest. Next, we have netstat minus F. Now, the problem with netstat minus F is not every connection actually has full name resolution. So if I take this netstat command and I do F, I'm not going to get full name resolution for all of these services. However, if I open up a browser, and this is kind of weird here in a second. There we go. We got the news. There we go. All right. I'm going to rerun this. And now it's attempting to resolve all of the different systems that my computer is connected to. Now, what you'll notice, unfortunately, is the vast majority of the connections that are made outbound from my computer right now are ads. So many ads, you guys. We got, what is it? A0003. We've got, Alchemy. We have all kinds of different ad services that are here. And that's one of the things I talk about a little bit later in the security class is I say block ads. Block ads are just a nightmare on your computer. It's just so rough. But now we can get some name resolution around these connections as well. And I'm going to close the news. Whenever you open up the news, it's like, who would win, Barack Obama or Donald Trump for a third term? They might as well just have an ad that's like, which religion is best and what's better, cats or dogs? Click this clickbaity clickbait link to find out more. Oh my God. All right. All right. So let's go ahead and let's keep going. All right. Next up, we have Windows processes. Once we identify network connections, much like we did on the Linux labs, we can then pivot and we can start looking. Oh my God. Okay. Sorry. Hold on. Excuse me. Once we have identified the network connections, then we can start investigating the processes associated with those network connections. We can find those suspect processes, weird things that may or may not be dangerous on our computer system, and we can start investigating those connections. So let's go to, once again, the single most boring command that ever existed on a Windows computer system. We're going to do task list. There we go. Ugh. Ugh. Not good. Not good. All right. So just out of curiosity, we're just throwing mud at walls here. If you were going to try to name your malware something, what do you think would be a good name for your malware that would just blend into the system? Just wonder if there's anything about all of these. What would be a good thing? Yeah. Okay. SVC host, right? Now, let's say I'm an enterprising young security admin and I want to do a search like, is SVC host malware, right? So we start doing some searches. Most cases harmless, that is, as long as it's a legitimate service. Cyber criminals can hide malware behind it because the service host process runs multiple instances by design. And you will find articles that talk about malware to protect yourself against SVC host. Now, a lot of these are like, well, you got to do your investigation. You got to do your homework. What? A lot of them don't even tell you how to actually investigate this appropriately, right? Because the task list command in and of itself, just by itself, is just sad, sad, very sad. But wait, turns out ogres have layers like onions. And the task list command has layers too in the form of switches that can take this particular command and make it awesome. What are the things we can do with the task list command? So let's take that task list command and let's do /SVC. All right. Up. Editors, I think we may have lost connectivity. Can you all hear me? Right, we're good. So editors, we're good. All right, let's keep rolling, rolling, rolling. I need to find another rolling song other than Limp Bizkit. I hated Limp Bizkit. I actually like them better now that they're old men because I just find it humorous and they're leaning into the old men rap metal thing. But I need other Rollin' songs. All right, so let's go through. Oh, Rollin', rolling on a river. There we go. Rolling, rolling, rolling. Gee, my ass is swollen. Swollen cheeks are swollen. Rawhide. All right, let's get back on track. Let's get back to it. You guys are getting me sidetracked. Gotta cut it out, everybody. We gotta cut it out. All right, editors, we're back to it. All right, so we have this task list space / SVC command. Now look how it transforms the task list command into something that's actually valuable. Because now, whenever we're looking at all of those SVC hosts, instead of those SVC hosts being utilized and it's just a standalone SVC host, now task list space / SVC is showing us what is the individual service behind each one of those process IDs. So you can see SVC host for 1284 is themes. You can see 1292 is prof service. DHCP is running on 1404. ENS, which is not SNES, which would have been awesome, but it's not that, is in the 1492, sailing the seas of blue, right? So you have, now you're able to directly correlate what is the service that is associated with each one of those SVC host commands. And that is awesome. But wait, there's more, right? So if we go into this and I do task list, I can also do a magical little switch of M. Now, what's really, really, really super cool about M is it shows me for every single process ID, what are all the dynamic link libraries that are associated with that particular process ID. Now we can start investigating based on what are the process IDs and the dynamic link libraries loaded into them. What are these particular processes doing? And that something that's really cool. And you're going to see how we get more information out of these executables after the lab that we're actually doing. But let's say hypothetically that you're on a computer and you're doing an investigation, you see a dynamic link library that's suspect, right? You're like, not sure if this dynamic link library is a real dynamic link library that is should be used on the system. So you can take this taskless command. You can take this taskless command and you can add a dynamic link after it, and it'll tell you every process that's using that dynamic link library. Now, one of the reasons why this is so incredibly cool is if you have a potentially malicious dynamic link library, odds are it'll be used in like one process. If you have something like ntdll.dll, a lot of times that dynamic link library is used across multiple different processes as well. So you can see how we take this one incredibly lame, somewhat pathetic, executable, and it can do amazing things. Taskless SVC, taskless M, and then NTDLL or whatever dynamic link library you're actually investigating. Now, let's say that you want to get taskless information for just a specific process ID. You can do this with taskless space /M space /FI. We're going to create a filter, and then we do PID equals, and then we give it that actual process ID. And it brings us up the information for just that process ID on that system. You can also use WMIC, which is in the process of being, well, WMI still exists, but WMIC is being phased out, and you'll be able to access WMI via PowerShell, be able to do this. So I'm gonna have to update the class to incorporate newer Windows systems, but every single Windows computer system up until like newest versions of 11 and new versions of server have WMIC. And WMIC is Windows Management Instrumentation Command. Now, we get some questions when we're talking about dynamic link libraries. Is it possible that I hear from time to time that malicious DLL uses the same as legitimate? And so how would you actually go about spotting it? You can do that. This is actually a technique that was created by Scape. He was on the Metasploit project, and he moved over and now works with Microsoft. And he has something called Scape JT injection, where you can take your dynamic link library and your evil processes, and you can inject it into another process on your computer system. And once again, the best way to detect it is network connection analysis. And we'll have another lab dealing with that tomorrow as well. All right, so WMIC process list full, I can get all kinds of information about that process. I can even go a little bit further with WMIC, and I can get the name, the parent process ID, and the current process ID. So I can see that kind of PS tree hierarchy of what process begat which other process on this particular computer system. Now you'll have like, the system idle process begat the system process, which in turn begat the system secure process, the registry process, and the systems management subsystem service. You can go through and find this entire mapping and hierarchy. And we're gonna have a lab a little bit later today. We're going to do this live. Then we're going to do it again with memory analysis, where we're going to run an analysis on a memory dump using volatility, but using the exact same techniques that we're discussing here as well. We can also get the command line invocation for executables, where we can do WMIC process, where process ID equals 808, get the command line, and it'll tell us how that command was actually kicked off as well. Now, there's a bunch of tools that make some analysis a lot easier. It's not quite full command line analysis, but it does make some analysis a little bit easier on Windows systems. One of those tools is Deep Blue CLI. This is a really cool little triage tool created by Eric Conrad that'll actually look at the logs on the computer system and how it investigates. So let's go ahead and let's jump into our Windows command line lab. Now, this is a really long lab. I like to give people about 45 minutes plus break. So let's just resume at 20 after. It's a good long lab, but there's a lot going on in this lab. So let's go into intro labs. We're going to go ahead and go back to our main ones. Go to lab directory. And we are going to go to Windows CLI, like so. And you're going to do some things to your system. Now, I want to show you something here real quick, all right? We're going to be changing the administrator password on your Windows computer system. Let me show you how that command works, and I'm going to show you an error that happens sometimes. So if I set the administrator password to 1234, it works just fine. The lab's going to work just fine. Everything's good. Everything's great. Everything's hunky dory. Don't have to worry about a single problem unless you close this tab. If you close the guacamole session like this, and then you try to reopen a connection via guacamole, error. And the reason why is you've changed the administrator password. If you get to this, it says login failed. What you have to do is you have to destroy the lab and restart it. So don't close your tab and try to come back after you've changed the password. Changing the password works just fine. The lab works great. Everything works fine unless you close your tab and try to come back into it. So just giving you a heads up on that as well. We're going to run ipconfig to get our Windows IP address. Then we're going to open up our Linux system. We're going to become root, and we're going to start MSF console. You're then going to use psexec to log into your system with Metasploit and upload malware. You're going to set the rhost to be the IP address of your Windows computer system. You're going to set the password to be administrator. In this example, let me edit this really, really quick. Never mind the man behind the curtain. Just give me a moment here. Got to change something here. There we go. Set the SMB pass. We need to set that SMB pass to be password 1234. There we go. Little update to this lab that I made. I got it fixed. Come on. Scroll down. There we go. On that. Oops. Commit the changes. There we go. Excellent. That's much better. So we set the password to SMB, the SMB pass to be 1234. Oops, I went too far. There we go. And then we're going to get our IP address on our system. So we're going to make sure that Windows Defender is disabled. We're going to start MSF console. We set the SMB pass to be password 1234. We're going to type exploit. It's going to log into your Windows computer. Now, I know that some of you are thinking to yourselves, wait a minute. A hacker is not just going to get someone to change their password and log in. True, 110%. You're absolutely % correct. However, the goal of this lab is to show you how to hunt for malware. So we're going through the most expedient way to exploit the Windows computer system. So just keep that in mind when we're going through this. All right. Then you're going to run netstat NAOB to start detecting the malware on your Windows computer. You're going to run netstat -f to see if there's any resolution. You're then going to drill into the process ID of the compromised process. And you're going to see these here dynamic link libraries here as well. Excuse me. Then we're going to get the command line invocation. And we're going to kind of explain what we did. We got the prior process ID. We found the malware. We created malware. We exploited systems. It slices, it dices, all kinds of fun things for people to get started. So like I said, I like to give this until, let's say, 20 after. Let's give this lab 20 till 20 after, and then I will do the walkthrough, and then we'll do the Ask Me Anything to close out the session. All right, everybody get to it. I'll see you on the other side. And here we go. All right. So once again, the goal of this lab is not to be like, here's how you hack a Windows system, or how you bypass antivirus engines, or how you do these things. The goal of this lab is you have malware on your Windows system. Let's hunt that malware down and try to identify exactly what that malware is doing on that particular computer system. So that's what we want to focus on this particular lab. So let's go ahead and let's go check out our cloud lab. I completely destroyed my VM, and then I brought that VM back, and it looks like it still has 35 seconds for it to start up. Once again, it's always a good idea to destroy your labs at the end. Like I said, in the previous session, I burned through a number of credits by leaving my lab VM on. In fact, with the lab VMs, they will run for 4 hours and then they will power themselves off. So it won't burn all of your credits, but it'll burn a lot of your credits. So 2 credits an hour, that's 8 credits. That adds up. So you do need to make sure that you're actually shutting these systems down whenever you're not using them. But mine has 4 seconds left. 3, 2, 1, and we are ready to go. Let's connect into our virtual machine and let's do this Windows lab. So the first thing that we're going to be doing with this particular lab is we're going to be opening up our Kali terminal, right? We're going to open up Kali and we're going to open up PowerShell. We're going to get the terminal ready. We're going to get PowerShell ready. And then we're going to disable the antivirus on the system in the form of Windows Defender. Now, once again, that may seem a little bit lame. How do you bypass things like Windows Defender? Once again, that's a whole nother class. We have a class by Joff Thayer that does implant creation that covers some of those topics associated with bypassing endpoint security products. But I'll give you one that we've been using at BHIS for a long time as a bit of a peace offering, as a bit of a truce. Many of the tools that you download from the Microsoft Windows Store do not have hooks for AMSI, for the anti-malware service. For example, you can download some versions of Python, no hooks with AMSI. You can run malware all day long in that Python environment. Or you can download separate versions of PowerShell, run those versions of PowerShell instead of the local versions of PowerShell, and AMSI will not be hooked into those. So you can bypass AV in a number of different ways. All right, so there. How's that for a good trade, right? So there we go. So I'm going to go ahead. I'm going to make sure that my system is running with the network connectivity. I'm going to open up a Kali prompt and I'm going to accept. Did you read the EULA? I'm going to accept the warning banner. We're going to go ahead and make this one bigger. Again, I'm going to go ahead and change that appearance, change that to a larger font. While I'm waiting for that, I'm going to kick off a PowerShell command prompt. Takes a few seconds for that to fire. And the first command that we're going to run is setting the MP preferences to disable antivirus, right? So we're going to disable Windows Defender, right click copy, make that 18, bold, yet not afraid to cry at a good movie. There we go, got that, paste that in there. Bam, AV is now down. All right, so now that we have that down, now we have to disable the firewall. Even though I did disable it by that GUI, we have the command in here just to ensure that the firewall is disabled as well. So I'm going to go ahead and just grab that command, just make sure that I've got it. I'm ready to go, just following the instructions as they are set in the lab. Next, we're going to set the administrator password to password 1234, like so. Just doing that copy and paste. There we are. And over here, I'm going to become root. I'm going to fire up MSF console. Run it in quiet mode. Don't care about the banner. Get that rolling in the background. I'm also going to get the IP address of my Windows computer system and kind of slip it off to the side like so. I'm going to slide that right over here because that's how we're going to be making the connection between my Linux computer system and my Windows computer system, is I've got to run the command to be able to exploit that Windows computer system on that as well. Now, the first exploit that we're going to use in Metasploit, believe it or not, isn't even an exploit. And yet, with that, it is one of the most commonly used exploits in the Metasploit environment. How is that? What does that mean? That seems nuanced and crazy. So it's not an exploit in the form of us actually doing a buffer overflow or a stack overflow, or even taking advantage of any type of coding mistake that somebody makes in writing code in Microsoft. We're literally using the built-in Windows commands to authenticate, execute commands, in this situation, executing a service on the remote Windows computer system. The reason why this is the most heavily used quote unquote exploit in the Metasploit arsenal is because once we gain access to a system with the standard exploit, it is very common for us to then use commands like this to move laterally around the Windows environment, taking advantage of the credentials and things that we've cracked. So we're going to use that exploit smbps-exec. Then we're going to set the payload to be Windows Meterpreter Reverse TCP. This is just the name of the malware is Meterpreter. It's a memory resident piece of malware that exists. The service generates it. Reverse TCP means it's going to make a reverse connection back to us as well. Next, we're going to set the rhost to be our Windows IP address, right? We're going to set the rhost to be our Windows IP address. And I kind of set that off to the side because I didn't need it right away. So we're setting the rhost to be 10.10. What is it? 251.147. There we go. Now I'm going to pull this up a little bit because it's dropping off the bottom of the screen. That looks so much better. All right. Next, what we're going to do is we're going to set the SMB user to be administrator because that's the authentication that we're taking advantage of. Then we're going to set the SMB pass to be password 1234. Like so. There we are. Next, we are going to do exploit, and it's going to authenticate to the Windows computer system, and it's going to compromise said Windows computer system with the existing creds. At least I hope it does. Nothing like live demos. There we go. And it looks like it's working. All right. So in a second, it's going to say interpreter. It's going to pop up, and then we'll have full access to that computer system, but it uploaded the PowerShell target. It actually started up a brand new service on that particular computer system. Service is starting. Ooh, I don't know why it didn't. That was weird. Let's see if this works. There we go. You know, it's like my dad always said, sometimes, son, you got to back up and hit dinner twice. So we just basically ran the interpreter. We had to run the exploit twice to get in, and we're in, and we're ready to go. Now we're ready to start doing some command prompt shenanigans to start investigating the system that we believe is compromised. So as I said, one of the first things that I like to do is I like to start with the netstat command because I like to look at those network connections on this system to get an idea of what bad things might be happening. Now, there's a lot that it just threw really fast on that screen, but I'm going to be focusing on established connections, all right? I'm going to be focusing on established connections. So you can see that I have established connection with Microsoft Terminal Service. That's my Guacamole instance. I'm talking to it. We've got JScheduled, and then here we have our PowerShell. I have two actual backdoors that are running. Apparently they both fired, but you can see that I've got this process ID of 6920. So I'm going to go ahead and I'm going to open up Notepad real quick. Now, normally I wouldn't actually run Notepad and keep my notes on the system that I'm investigating. I just want to make that clear to you all that it's generally a bad idea. I wouldn't recommend that at all. But I'm going to grab these two instances of PowerShell. I'm just going to investigate one, but the process will be the same for both of them. So here we've got the established connection. I've got the process IDs associated with each of these PowerShell instances. There we go. And I'll just investigate this one right here. So we got the 2548 is the one that we want to drill in on, right? So I got that network connection. Now, you may ask me, how do I know that that's evil? Well, first and foremost, PowerShell is like you generally don't see that running on a lot of workstations persistently. Now, it is absolutely possible that somebody has a program or something that they set up that does in fact use PowerShell. But if it's running PowerShell, it's a little sus. You would do some investigation, but normally you would start looking through all of these different connections that have outbound connections to internet IP addresses that aren't related with standard web browser traffic. It would usually take a lot longer to do that investigation on a host. But because I know the malware, it allows us to cut to the chase a little bit faster. I can also do netstat -F on the Windows computer system to see if there's anything that resolves to strange domains or IP addresses or anything that doesn't actually. Because in this situation, the connection back to our Linux computer system is a connection that's a raw IP address connection. There is no fully qualified domain name associated with that connection going back. And you can see it right there. We've got two of these are 4444. We have two separate connections to our Linux computer system. So that's kind of weird too. Next, we're going to dig into that process ID by using the task list command. And we can look at both of them. We might as well. I mean, it's fun. We've got time. Let's do it. So I've got this one. I'm going to go ahead and pull this down. I'm going to pull this up. There we go. Maybe yeah, that's good. That works good. I like that. So we're going to go CLS. I'm going to put in that task list command, and we're going to replace that process ID with 2548, like so. And we've got services controller host. I might be looking at the wrong, oh, I am looking at the wrong one. Let's look at the right one, huh? All right, so let's put in 69920 or 6920, put in the double quotes. There we go. All right. So there's a bunch of really, really interesting things about what we have here. Like first we've got PowerShell, but we also have these dynamic link libraries that are being used on this system as well. And what's interesting about those dynamic link libraries is the NTDLL is the kernel. We have whoa 64 base. Does anybody know what whoa is? What are the whoa executables on this system? Anyone know? Any takers? All right. Those are Windows on Windows executables. All right. So I just start up at, oh, hold on. Let me finish that one out. All right. So I can start up another Netcat listener on this system. And I want to show you kind of what it looks like with some really, really, really basic, really super basic malware, because Netcat is about as basic as it actually gets. So I'm going to go ahead and rerun the netstat command right here. Netstat NAOB. And we're going to look for my Netcat executable that's listening on port 2222. So if I scroll down, we're looking for port 2222 on our system. Sorry, I got to zoom in. My screen that I look at is way too far away for that. So I'm looking for listening Netcat on 2222. Wonder if I'm missing it. If you guys see it, just give me a thumbs up, because then I know that I'm an idiot. And oh, I got heart. So let's go through. This is what happens when you go off-roading. I might have to make a connection, then it's easier for me to find established. We're going to do that. So I'm going to open up another Windows. Did I actually start it? Yeah, I did. All right, so let's open up another one and just connect to it real quick. And then it'll show up pretty quick because it's established. There we go. Now we're connected. And now if I rerun the netstat command, it's going to be easier for me to find established connections than looking for open connections. Let's go up. Here we've got our established. Okay, all the way to the top. All right, so we've got established 444424. There it is. All right. So here we have Netcat listening on this particular port, and you can see that its process ID is 1576. So I'm going to show you what malware looks like with Metasploit, right? Like that's Metasploit using PowerShell. So we've got Metasploit using PowerShell. We've got these core dynamic link libraries. And now what I'm going to do is I'm going to look at the Netcat executable and what dynamic link libraries it's using. So let's go ahead and zoom in on those. All right. So you can see that our PowerShell malware is running the exact same dynamic link libraries as our Netcat malware. Excuse me. Now, does that mean that all bad malware is going to use these exact same dynamic link libraries? No. A lot of malware can actually inject itself into other executables. You see a variety of different things. But when you're looking at malware and how, like, what are the core libraries in Windows that are required for it to actually function properly? Well, there you have it, right? These are the absolute bare minimum dynamic link libraries to create a piece of malware that opens up network connections and allows you to get like raw access to the command prompt on the Windows computer system. So like I said, a little bit of off-roading. Let me go back to my lab instructions. There we go. So there we go. We just did some investigation by using task list. We can also pull this with WMIC. As I said, this isn't going away in this class, but I'm going to augment it with some PowerShell that does the same thing. So let's go ahead and do the process ID. Let's go ahead and do the netcat process ID. Let's do 1576. And you can see the netcat command line parameters that I did to execute show up there. Now let's take a look at the PowerShell, which is 6920, like so. Oh my God. Yeah, that's weird. So this is completely obfuscated and encoded PowerShell to try to bypass your EDR products. So that's what malware looks like in PowerShell. Yep, totally safe. Totes legit. Nothing suspicious about this at all whatsoever, right? All right, so let's go ahead and let's get the parent process ID for this process as well. There we go. Let me rerun a couple of commands here real quick. Oops. There we go. Got those. Oh, I did not want to do that. I went too far. And now we've gone too far. There we go. I've got netcat. And then I also have the process ID of our malware 6920. So let's go ahead and get the, I needed that 6920. I'll do that. Paste it in. Let's recopy it over here. Right click copy. Paste that in. Now we're going to set that to 6920. Like so. Oh, I got to be in PowerShell for this command. Give me a second. Let me open up PowerShell and we'll rerun it there. Six nine two zero. There we go. So now I can see that PowerShell.exe, right, actually has a parent process ID. And then you can see that it invoked connection host. That's how it made its connections going outbound on that as well. So now if we do that with our netcat executable, let's try to do that same thing to finish this out. Look at our netcat executable, which the process ID is 1576. That. You can just see it's netcat because it just ran basically from a command prompt. So pretty easy peasy. All right. So once again, we're kind of coming back to kind of closing this out. We're going to get to Ask Me Anything. But the point of this is like, these are the tools and these are the things under the hood that you need to be able to understand if you want to start detecting malware. By the way, I'm going to take a second and I'm going to destroy my lab. Don't want to burn those sweet, sweet credits, right? So that is the lab on Windows. We're going to pick up, we're going to do some stuff with Deep Blue CLI tomorrow. We're going to talk about doing some quick triage analysis of log files, but right now it's all about you. So what questions do you all have for me? Could you please explain? Whoa, geez, that just blew by really, really, really fast. Hold on. My Discord's going by quickly. Just keep seeing the Hulk. All right. Could you please explain WMIC that we used at the ending? It's Windows Management Instrumentation Command. On a Windows computer system, if you just type WMIC, you can then hit question mark, and WMIC gives you a tremendous amount of functionality in querying the status of the Windows computer system. And it's actually using very similar to like SQL style commands. Like you can do select string where a value equals a string. And it just is a way of querying information out of the Windows computer system. And I don't know why Microsoft is getting rid of it. I know that it's still going to be there. We can still use PowerShell, but WMIC was awesome. It could be they're getting rid of it because hackers use it. I don't know. I have absolutely no idea at all why they're doing it. Does the payload automatically set to reverse TCP unless you, yes, it does. It explicitly sets it to Meterpreter reverse TCP. Absolutely does. What else we got? We got Mr. Clippy. Is there a way to get the payload has been executed? We get that Meterpreter session back, and that's a pretty good indication. What tool would you use to sift through the attempted PowerShell obfuscation, or would you not? I really wouldn't. I know that there's people that do, and they have that capability, and they're awesome. People like John Hammond. I wouldn't use CyberChef, actually. Um, a lot of CyberChef, it is using base64 encoding, but there's a lot of different types of encoding that it's using, and it's also inserting additional characters that are not base64 characters. So you'd have to do like base64 decode, ignore garbage to get it across as well. Do we really get this much access to systems to do analysis? You sure do, Mal. In the event of a hack and a company's compromised and everything's shut down and the insurance company's breathing down their throat, you'd be surprised. And as far as like getting this much access, I've been doing this now for 25 years and I built an entire company from scratch around doing these things. So, I think everyone's mileage will vary, but this has worked really well for me and what I've been doing over the years as well. Within time constraints, is there a quicker way to go through the services? If you start at the network connections, that really limits the number of processes that you have to look at, right? So if you're focusing on network connections and then looking at the services that way, it goes much, much, much faster. None this training unless you have time. Could you show us how real malware and how to get into a black box type environment? Yeah, not in this class. We have, what's his name? Rhino. Michael Allen's class, Initial Access Operations. And we have an entire continuous pen testing team that's all they do every day. Every day they wake up and they're like, how do we break into our customers' environments? And it isn't in a week, it isn't in 2 weeks, it isn't in a month, it's every freaking day. So like last week, we came up with the new bypass techniques for AV. Matthew Eisenberg came up with that technique, and we've been working with our developers in India to refine it. And sure enough, we've got a technique that we've been using to gain access to systems on that as well. Where would you recommend learning more to get like information on Metasploit works? There's something called the Metasploit Mega Primer. And also, if you do a search for offensive security Metasploit, there's all kinds of step-by-step guides for Metasploit. And I'm working on it. I'm really, really frustrated. I just haven't had time. I want to create a Metasploit class. Now, if you're working professionally as a red teamer, you're not going to use Metasploit. You're going to use Cobalt Strike. You're going to use Brute Ratel. You're going to use Outflank. Outflank Security is an amazing group of security researchers out of Europe. And Outflank has a whole bunch of post-exploitation techniques that bypass AV. So we work with Outflank, we work with Brute Ratel, we do Cobalt Strike. We don't use Metasploit all that much. Also, if you like that class, that Michael Allen class, we do have a full catalog, like all of our classes, every single class. It's like 50 classes, I think. Access to everything that we have on demand, and that is available for $1,500 a year. So if you want to, you can totally get that, and we'll get that link for you. It's our Black Friday sale, which we never shut down. But if you want to go through, you can totally check it out. No one ever really buys it. I don't know why. It's like 97% off list price for our classes. But yeah, it's every single class we have for the price of 3 of them. Thank you for the Sham Wow guy. That's awesome. That's there as well. Will you cover Active Directory attacks and detection strategies? Really grateful if you cover these. Yes, we actually do have some enterprise log analysis sections. We're going to talk about UEBA, and we have a lab where we're going to talk about that. And we're actually going to be talking about it. We're going to talk about Deep Blue CLI, and then I'm going to show you how Deep Blue CLI detects password spray, lateral movement type attacks out there as well. So yes. Yes, we do. That is coming. Can you explain how WMIC can be used to store malware to maintain persistence and avoid? Now, most of that research was done by Chris Trunser. If you want to look at his talks, Chris Trunser did a number of Black Hat talks on using WMIC, and it was absolutely crazy. You can actually do it where you can have multiple aspects of the malware spread across multiple different computer systems. So go check out Chris Trunser's work on WMIC malware. What would be an indication of malware present to prompt you? Believe it or not, a lot of times it's AV. And the reason why I laugh about that is if you have AV and it says, oh, look, there's malware. A lot of people will be like, well, it got it. Not necessarily. Um, I would say a huge percentage of our work, the customer got an AV alert, but it didn't fire fast enough, and the malware was able to start spreading before they were able to stop it as well. So kind of crazy. You made a comment about Pop OS and not liking their computers. I love System 76. I love System 76. I want them to be successful. So here's my problem with System 76 and Pop OS. Their computers were awesome, right? But when you're looking at what they've been focusing on for the past few years, they've been focusing on the cosmic desktop. Why the world needed another desktop in Linux, I have absolutely no idea. If you want a Linux computer system, I'd recommend System 76. If you travel with a Linux computer system, don't. Their build quality is just not at the point where, unless they come out with a new like MacBook Pro aluminum type thing. But my System 76 systems, as much as I love them and everything works and it's great, they just aren't built that rugged. So what I'm using now is I'm running a Lenovo ThinkPad. I think it's an X1 Extreme, and it's running Fedora. And I had it in, it came pre-installed with Fedora, so it was ready to go. So, all right. Yeah, X1 carbons. I actually broke my ribs. I broke two ribs in three places on my X1 carbon. I was walking across a parking lot and I slipped and I fell cartoon style. And it was a parking lot in a ski area. And it hit right here. And then my daughter's ski boot hit the back of my ribs and it punctured a lung. And my daughter got her learner's permit, and I couldn't drive because I was absolutely just freaking out. And I was going into shock and shaking. And she actually ended up driving me home and then eventually took me to the hospital. And I spent the night in the hospital and things like that. But no, the computer was fine. The X1 Carbon was fine. It was good. It was a little bent, but it still worked just good. Do you buy gaming laptops in order to have GPUs? Yes, we do. I don't have it on my traveling computer because I honestly don't care about games all that much. But our pen tester notebook computer systems, I can't remember what they are. They're like super beast Lenovo's, and they do have a dedicated, like full on, like NVIDIA video card in it. I don't game, right? And also the other thing is we have a full password cracking system upstairs in, I think it is the Legion. I don't think it's the Legion. It's one of the business ones, but we have a full password cracking rig. We have the Kraken and Cthulhu upstairs. And then we have Squidward and Cuttlefish. We have some smaller password cracking systems as well that we use. So if I need any password cracking, I'll just throw it up there and let it do its thing. There we go. Oh, I've got to get that link for Prism because I'm looking for phones. Really, I just want a Linux phone. And I want one that actually works, which is a problem, but it's kind of hard to de-Google your life as much as you can. I don't know about the Liberty phone. I don't know if anybody's run it out there, but definitely looking for ways to kind of get a little bit better with not being monitored constantly by Apple and by Google on that as well. Can you share that about that guy? His name is Chris Trunser. Let me see if I can find it. WMIC. There we go. Oh no, his website is down. Chris. What's going on, dude? All right. Here's a B-Sides Augusta video of his. Let me share that link real quick. Let me throw it in. There we go. All right, so there's Chris's WMIC talk, one of them out there as well. Did I not get the right one? That doesn't look like the right one. Huh. Okay, that's Chris for sure. Let me give you the Bing link, which is weird because I'm using Bing to get you to a YouTube video. Because when it went to YouTube, it didn't go to the right one. All right, there you go. Any opinions on this guy's network classes? I don't know. Let me check it real quick. Does he mention the OSI model?
Hopefully that's not a honey link.
It could totally could be. People know how to like get me really easy. Not seeing anything on OSI, Megan. I like him. There you go. There you go. All right. All right. Any other questions for you folks? Got a couple people typing. What's for dinner? Beef. I don't know what I'm going to do for dinner tonight. I have leftover Indian food. How's that? Probably do leftover Indian and maybe just some hummus and some vegetables.
That sounds yummy. I love hummus.
What characters are considered to be valid in base 64 implementation dependent? Decoding tools will not always be enough. Well, you can encode in a variety of different ways, but you're looking like upper, lowercase, A's, B's, C's, alphanumeric numbers are base 64. If you get into like a plus slash, those are not valid. And the equal sign is used as padding for base 64 as well. Quesadillas, gotta like quesadillas as well. What is the best combination of certs? There is Any Class by Kent and Jordan. That we can get those classes out here at Anti-Siphon are amazing courses. So check those out.
I'll grab the links.
Thank you. And did we get the link for everyone to pay for the full course subscription catalog? Everything. And the
Yep,
cyber
it's in there. It's in there.
It's in there.
We keep trying.
Is
We're
it in
gonna
the
try it every single
resources?
class.
Okay. Also, Megan, do we want to drop in the instructions in resources for? Oh, you got it. Also, can I share my screen again real quick? I said I was going to talk about this tomorrow, so tomorrow is today. All right. In the resources, we have this. This is the Anti-Siphon ACE-T Core certification. Now, I want to set this up so you know this is in resources. You all can get this. I hate multiple choice certification tests, like a lot, like really, really hate multiple choice certification tests. So what we did at Anti-Siphon is we created a multiple choice certification test. But bear with me. Let me explain why. With a lot of multiple choice tests that you do, you end up paying hundreds of dollars, sometimes thousands of dollars for a certification attempt. And I hate that, right? My wife has this joke with me where she says, someday, John, I hope that we can make as much money as you've cost other corporations. And I think that that's a good goal. But I hate multiple choice certifications, especially if they're thousands of dollars, because it's not that hard to create a multiple choice certification test. Like you don't have a bunch of people walking around in lab coats with like little, notepads and they're writing stuff down and it's not that's not how it goes. Like there's no Tesla coils in this. So I decided to sit down with a bunch of people and we wrote a bunch of multiple guest questions and created our own. But this one is pay what you can. And we can call it pay it forward. The minimum cost for it is $5. $5. That's it. It's like less than a cup of coffee at Starbucks. $5. Okay? All right. So we set this up. You go through, you pay for the certification, you register, and then once you get into the portal, you have to do this in two different steps. Well, three, actually. The first step is you take the multiple choice test questions, okay? You go through, you answer all the questions. You pass. Once you have passed the questions, you have to do cyber range challenges. You have to pass a certain number of the cyber range challenges. And then the third step is you have to submit a write-up of your multiple choice, of your cyber range challenges. And then that is stored with your certification. So you're like, hey, I'm certified ACE-T Core, and here is a write-up that demonstrates my communication capabilities and writing capabilities and technical aptitude. And that are 2 write-ups. Thanks, Andy. 2 write-ups. And that's your certification. It's not just pass a test. Pass a test, write a paper. And I'm not going to judge it. No one in anti-siphon is going to go through and judge your paper. But if you put it down that you're ACE-T certified, the people that are going to hire you are. And that's going to be the judge of you and your character and your ability. So you get a test, you take it, you do some solutions to some challenges, you do some write-ups, and that's you in a nutshell, right? So you go through and do that. And that's it. $5. Because once again, I hate people charging this much stuff for it. By the way, it is in the resources, and it's right here, MetaCTF ACE-T Core Cert. So that's what we're doing. Once again, I just trying to change things to make things better. So now you can put it on your resume, and it's not just training, it's also this. And it incorporates 2 of these classes, this class and the Intro to Security. And Raj, by the way, I have a bunch of my Pay What You Can classes. If you go to Anti-Siphon on YouTube, go to live, you can see all of my previous sessions there. And we have the certification. Raj, we're going to get you a job, man. That's our goal here, right? Does the bundle include the new CIS course? No, it does not. That CIS course is separate. That CIS course is like $1,500 on its own. That's a whole nother ball of wax on that, but it also has continuing updates and all kinds of additional things on that as well. All right. So with that, everybody, thank you so much for your time today, and I will see you bright and early tomorrow. So get kicking, get hydrated, get rested. Talk to you later.
All right, everyone. Have a good night. We will see you tomorrow for day 3. Daryl, go ahead and kill it with fire.